we are doing a different, well, it's the same chain rule, but different examples. Yesterday we did examples pulling the information from a table, and today we're going to have only two examples, one with the exponent right there, and the other one will be under radical. So here we go. It's the same formula for the chain rule. We have the outer function, we have the inner function, and then you know it's the composition function, blah. So you're going to take the derivative of whatever g of x is, and then you're going to find a derivative of the inner function. What does that look like? So I like to start out by organizing my information here. I like to do the outer function and the inner function so I know what I'm doing. So the outer function is, no matter what's inside, this is the outer function. So whatever that is, raised to the fifth power. The inner function is just simply 2x plus 1. It looks like 2x plus. It's not, it's 1. Okay. So now we're going to apply what we have here to the formula. So for me to find the derivative of y, I will derive this applying the derivative, the power rule. So 5 goes right there in the front. So 5 goes right there in the front. Now, why don't we do this off to the side? Okay, 5 goes in the front, and whatever I have on the outer function, I just minus 1 from the exponent. So that makes 4. Let's find the derivative of the inner function as well. So I have the invisible exponent here. 1 drops to the front, 2, and then I have 2x, take away 1 from 1, I have 0. Anything raised to the power of 0 is 1, so I just simply have 2 times 1, it is 2. Or, you know, from basic derivative, you know the derivative of a linear function, it's going to be the slope of the line, so just 2. There's different ways for you to find the same thing, but basic function, you just got to know what it is. You don't have time to be calculating that. Anyways, back to the problem here. I will do the derivative of the outer function, 5, and then 2x plus 1. I have a 4 right there, and then times, I'm following that, the derivative of g function, so 2. Now put it all together, make it pretty. So the derivative of this function right here, 2 times 5, 10, and then 2x plus 1 to the 4th power, voila. You can choose to do this off to the side or not, doesn't matter. I like to because I like being organized. So example 2. Okay. So I will separate them in outer and inner functions. So the outer function is this one right here, but I'll go ahead and rewrite this with the exponent. So the outer function is this one, and because it's under the radical, I'm going to rewrite this as the exponent. So let's say this one is x squared plus 1, and then to change this from the radical to the rational exponent, you make that as a fraction. Invisible 2 right here for the index, so 1 over 2. But because it was in the denominator, that's reciprocal, so make that the negative exponent. Okay, so that's my outer function with negative 1/2 as the exponent right there. Then the inner function is this right here on the inside. Okay, find the derivative of that. So that goes back in the front, negative 1 over 2. Take away 1 from that. Find the derivative of that one. So 2 goes to the front, multiplying as the leading coefficient, and then you subtract 1 from the exponent. That makes exponent 1. Invisible 1, you can choose to put that or not, whatever. Okay, apply the chain rule. So the outer function, right there, what goes there? The inner function, so x squared plus 1. Exponent, times the derivative of the inner function. Okay, make it nice and pretty. 2 divided by 2 is 1, but we have a negative right there. So negative x for your numerator. This is negative. It goes on the denominator. But we're going to go back and change that into the radical. And then 3 is the exponent. And the 2 is the index. Since 2 for the square root is the index, that's the default. You can choose to do it or not. It's 3 right there. It looks a little icky, but it's 3. It is not bad. As soon as you do a couple of them, you'll get the hang of it.